Thank you, Mr. Customer, for giving me the opportunity to highlight some of the things about our cyber resiliency workshop. The workshop encompasses these four key pillars that you see: anticipate, withstand, recover, and adapt. We'll use these as a basis for our discussion as we walk through our data center environment and how we can make our business more resilient. So to begin, we have our data center architecture. So here on the left, you will see we have a perimeter edge router, perimeter firewall. We have the data center core network, which in this case we're showing a spine leaf architecture. Not necessary, but just for the sake of this architecture to build on. Then we have our compute stack with our virtual machines. We have some storage at the bottom, and then we have a data protection system as well. So as we think about making this a more resilient architecture, the first thing we want to do is spend some time anticipating what could happen. And as we think about anticipating, we can't help but to think of zero trust architecture. It's something that's very common. We hear about it all the time in the industry. And it's important because if we don't protect the architecture from our users, from external forces, making everything zero trust, and we set ourselves up for compromise on a security side. So we put a couple red blocks over here indicating some firewalling. We could make sure we have a firewall here at the entrance to the data center. This will help to enforce zero trust on our machines from a user perspective. We inspect their traffic, make sure that the connections are clean, and then only let users get to the workloads that they should get to. Further locking that down would be some kind of a microsegmentation or firewalling strategy on the virtual machines. Only allow the virtual machines that need to talk to the other virtual machines or servers. This is great because, number one, if someone does compromise a machine and has lateral movement, they can only get to the other machines that are connected or that have visibility. Secondly, that's the blast zone, right? So if someone does launch an attack from there, theoretically, just those small few machines are affected. So great ways that we can anticipate and then protect the network. This helps keep everything up and running and available. Something else we could do is a business impact analysis. Now, this is not something offered by A&M, but we have partners that do. And it's an opportunity to map the business function and the applications that are critical to the business to the availability of the environment, of the data center. Now, why is this important? If we as IT people were to go to the application owners or to the users and ask, of these, 30 applications, these 100 applications that we're running, which ones are the most important? No, they would say all of them. And if we say, what are the RPOs and RTOs needed? If there was a disaster, they would say, well, they all need to be zero. Everything needs to be up all the time. And we know that that's not practical. So business impact analysis gets some access to business leaders, business thinkers in the organization, and they can provide feedback as to what's really important, from a financial standpoint, from a compliance standpoint. What is it that really needs to be up and running? And what do we really need to focus on protecting? That can help us to design a better resilient network that meets the goals of the business. That can be a long, costly engagement. Not everybody can do it, but it's something to think about. On a smaller level, there are disaster recovery plans, incident response plans. A lot of organizations put some level or some thought into these and implement some level of planning in this area. And we encourage that too. There's certainly nothing wrong with that. Of course, the goal would be to test these things out and make sure that they are operational, functional, if there actually ends up needing to be a need to enact them. So that's anticipate. How about withstand? Well, in order to withstand an attack, we have to have redundancy. And so redundancy includes a lot of things. First of all, inside of our data center environment, we want to make sure that the hardware is redundant. Wherever possible, we have redundant firewalls throughout, redundant switches, redundant power supplies. We have possibly redundant power coming into the building, redundant circuits on the outer edge for connectivity and communication. They even have backup power, backup generators protecting everything. Along with that, we may even build another data center. So that could be another way that we're going to withstand this attack or withstand a disaster, is if side on the left goes down, we can fail everything over to the side on the right. Now, one thing we'd have to also look at is whether or not DDoS is something that we need to be able to withstand. The business impact analysis can help with this, or even just a careful consideration of whether or not an outside attack like this would be hindrance to the business operation, and what's the level of impact. So, if it were something like a Cloudflare or some other outside edge provider can black hole that traffic and provide a protected layer. But as we look at this data center, secondary data center, we might give some thought around where we put it. We wouldn't want a geographic disaster that impacts the left side, a fire, flood, storm, whatever it is, to be also affecting the right side at the same time. So as much as possible, these should be geographically dispersed in order to provide the most resilient architecture. As we build this, we'll probably settle on one of two models, either an active standby model or an active model. Active standby, a little easier to manage. Everything is always operational on the left. And then if something goes haywire and we have to fail over, we bring it all over to the right side and we're up and running. The bean counters typically are not very happy with this because all of this is just kind of sitting idle more or less, and just a nice insurance policy. So many businesses will go active, which increases complexity between the two environments, but also gives you the ability to have workloads running on the right side and the left side, and everything can fail over back and forth. Along with that, we might need to drop in a load balancer, probably a cloud-based solution of some kind. So wherever the workloads may be and wherever our users may be, we can get our users connected back into our applications. So those are a couple things to think about when we talk about withstanding the attack. Next, we have recover. And for recovery, there's two key things that come to mind. One is clean rooms and one is cloud. Let's talk about clean rooms first. This is something that we would use to help against a cyber threat, like some kind of a security attack. The clean room is a separate infrastructure. Right? So compute, virtual machines, and storage, it could be on-prem. We're not necessarily designing this around like an actual physical disaster. It could be in a colo facility, or it could be just about anywhere we want to put it. And it doesn't have to be as big as what we have in our primary network. Again, the business impact analysis would help us define what needs to be here. What are the critical applications that we want to bring up if we can't run them in one of our primary data centers? Now, the link between the clean room and the actual primary network should only be activated once a week, once a month, just long enough to replicate a copy of the storage over and to patch and update all of our applications, our VMs, our compute stack, and then cut the link, turn it off. The reason this works is because once we kill that link, if there is some kind of a compromise and the bad actor is able to encrypt all of our data, let's say on our primary and secondary storage, well, now we have a clean copy. We have a clean environment that we can come back up in. Talking through that a little bit, see our virtual machines here in the primary network are trying to come back online. We need to have primary storage to get these back up. But often what we see is that the business can just turn this back on right away. The security teams, the SOC teams want to do a lot of forensic analysis. What happened in the environment? What servers were hit? How were they hit? How did the data get encrypted? Did the malware hit a person's machine? Where is that machine? A lot of analysis has to happen. And then some organizations will require further scrutiny by outside organizations that might come in and also want to check and see what's going on, what happened. The net is that these storage systems could remain offline for some time. Could be weeks, could be months before these systems can be reactivated. So where are the VMs going to go? The VMs need a place to commute, to talk. They need their storage. The answer lies in a couple places. One is the data protection system. Now, a modern system like a Rubrik allows you to mount some of your VM or get your VMs going again directly on the data protection system. But the entire line of business that might need to come up really requires primary storage. So with our clean room, we can make a connection from our data protection system into our clean room. We can push our backups onto the storage system, making sure we get everything up to date, and then activate these VMs and get the business back up and running while this storage is down. This allows us to operate until we can completely recover this. So it's a nice solution, something to consider to help mitigate if there was some kind of a ransomware or other paralyzing security attack. Let's talk a little bit about cloud. Cloud is more going in place to help resolve disaster. right? Not necessarily a security disaster, but an actual disaster. Some organizations are looking at cloud instead of a secondary data center. It's a little cheaper theoretically because I don't have to have all this infrastructure. I can maybe pay as I go, right? Put a little bit up here, kind of only put up here what's critical. But there's a lot to building a DR in the cloud, right? Azure, AWS, these are places people often look, and it's a do-it-yourself approach. So you have to not only bring up your compute, your storage, data protection. Oftentimes you have to translate this into the cloud language. There's a whole networking piece where you have to have, sometimes you have your public domains, your private domains. You have to interconnect between them. You have to put security in there, making sure everything is operational. But to think about remote access or access to the cloud from our remote users. So maybe the system, the data center for some reason is unavailable. Maybe we have users still in the building, but they're going to have to go to the cloud now. So how do they get there? Or now we've sent everybody home because there was the building burned to the ground and we don't have a data center. We don't have office space anymore. So how about these machines? How do we make sure that they can get access? And that opens up a whole nother discussion about the secure service edge, right? So lots to consider when we think about bringing everything into the cloud. It's not a simple thing and certainly not something we would want to undertake in the middle of a disaster. One thing that might help some organizations or would help some organizations is VCDR, which is vCenter Disaster Recovery. This allows you to bring native VMware into the cloud. So instead of running like EC2 instances, we can actually bring VMware into AWS. These can also be put into a pilot light state, where once we get them all set up, we can kind of put them in a standby mode or a sleeping mode. They're not consuming any CPU cycles. And so our cost to put this in the cloud has now gone down considerably. When there is a disaster event, we can push the big red button in our vCenter. We can say, hey, we need this active. We need to bring this online. And so then these machines wake up, they connect to storage, and everything starts to operate. So a nice solution. It is AWS only, but it is something that can help automate the process and make using DR in the cloud a possibility. Now, something else to talk about in the cloud realm is data protection. So why might we consider something like a backup as a service? If we think about our data protection system on-prem, if there were a bad actor that compromised everything down here and we had to go into this failover mode, our data protection system could also be compromised from at least a credential standpoint. We might have immutable copies here, but whoever escalated privileges, got access to systems, created all the havoc in here, probably owns this system as well. If they own this one, they probably own this one. So now we have no way to push clean information over into our clean room. But if we did backup as a service, we can replicate from on-prem into the cloud. Since the cloud provider is responsible for the credentials up here, we're just pushing data in. We're not actually managing this. Somebody else is. In that case, we had to have a protected copy that we can gain access to. We have one more cloud solution to talk about, and that's over here. This is Disaster Recovery DR as a service. And you'll notice that it looks a lot like our infrastructure as a service. We have virtual machines, we have storage, we have data protection, we have firewall, remote access. The nice thing here is we have a company that is just helping us to set up, operate, manage, and protect all of this, and then help us to do failover testing, run books, etc. So if we don't want to do it all ourselves, then we can actually outsource it. This helps us to be more nimble. It does have a monthly fee associated with it. It is an as-a-service offering. So, the business would have to check this out and see, does it make sense? And A&M partners with a couple different companies in this space to help with that discussion, should that be of interest. Our last pillar then is adapt, which has a couple things to just review. If we did experience a cybersecurity event or we did experience an actual disaster, it might be a time to come back and do a lessons learned, right? Maybe there are things we need to harden when it comes to a security standpoint. Maybe we need to look at different security controls, dive deeper into zero trust to help prevent an attack like that from happening again. We might want to re-architect or transform if we were hit by a disaster that took out a significant portion of our data center, or maybe we went to the cloud. Maybe we have this AWS or Azure setup. Maybe we started down this path and then we actually attempted a failover, or we had to try to failover because something went down and we realized things were not coming up like we'd like. So maybe it's a time to move to an as a service offering. Lots of things to think about, but adapt is similar to anticipate. It's going back and kind of reconsidering things that we can do to ward off the attacks so that we're in a better position. Well, I hope you enjoyed that overview. There's a lot of information we just discussed. The workshop goes a lot deeper and into your environment, and specifically how these different pillars can be analyzed in your environment and make your infrastructure a lot more resilient. So when can we get that scheduled for you?